Hello, today we're going to work on our 10.6 and 10.7 review. I'm going to work on a few of the problems from each one of these. I'm not going to work on all of them, that way you guys only have to do a little bit, and I have all the information for you since this is a review. We're just going to start off with problem 1. Name any radius. We have to remember a radius starts from the center and goes to the outside of the circle. So I just labeled one, and I'm going to call it AC. And since it's a radius, it is a segment. Remember that. Diameters could be the same thing, but I'm going to label a diameter for you. A diameter is very similar to a radius, but it is double of what the radius is, and it still goes through the center. So you can see in this one here, I have from points D to G should be a diameter. Now, a semicircle is half of a circle, so you could start from D, go all the way to G, but we have to denote that we are going to be utilizing another point. So D to G as a semicircle, it's a major arc. So we're going to go through at least one of the points on the outside of the circle, or the circumference of the circle. So we're going to start with D, we're going to go to G, but we're going to go through either C or B, and I chose to go through C. Doesn't really matter. And notice that I'm using now this arc because it's the outside. I'm using a semicircle, so I want to make sure that we have that symbol. Number 4 is a minor arc. So in this case here, I'm gonna use the idea of going from, in this case, D to F. So I'm gonna highlight it so you guys can see it. I'm gonna go from D all the way to F, and this is the shortest route. So this is what makes it a minor arc. It's the shortest or the fastest route. So D to F is the fastest route. But if I want a major arc is the same place. So in this case, I'm going to go to D to F, but I'm going to go around the long way. So this is the purple or the pink here. And so I got to go from D through C, through B, through G, through F, but I only want to choose 3 points to write it in. So I'm going to choose, in this sense, I have my starting point D, I have my ending point F, and this time I'm going to go through B. And again, this is that arc. So you could see with this one here, we're going to talk about all the major vocabulary first: radius, diameter, semicircle, minor, and major arcs. And that's just the naming component, and that's what helps us find lengths and measures. So in this case here now, you could see that with number 6, it wants us to find the measure of the arc from F to G. So F to G. It wants us to know that much. That's a minor arc, a small. But with number 7, it wants us to find DFG. Well, that's a major arc, DFG. And we probably already know that this one is probably going to be a semicircle since it's connected with a diameter. But I'll let you guys solve that one. Then for number 9, we have EB. So finding this minor arc of EB, it is the shortest route. And then finding the major arc of ED or EBD. And actually, this one's kind of funny, because if we're following what it's saying, it says go from E to B to D. So hopefully if you're watching this, you can see how many degrees this is going to be. Alright, now I want to choose to do number 6. I want to try that one. Number 6 is FG. We already know here that this segment, or this arc measure from E to D, this arc measure is 90 degrees. E to F, that's 74 degrees. Well, F to G is going to be what's remaining of this semicircle, so it's 180 degrees. So we're going to have 180 degrees minus 90 degrees minus 74 degrees. And if we do this correctly, 180 minus 90 is 90. 90 minus 74 is going to equal 16 degrees. So you found that this is 16 degrees, which is great. That's what we wanted to do. We wanted to find out that was 16 degrees. This is the premise that we're going to be working with each and every time. And we could have even taken a shorter cut and said, hey, if the arc measure of ED is 90, then EG, this whole entire thing, is also 90. So we could have skipped the whole 180 step, but I figured that we should see that it is a semicircle. Alright, let's move on to 11 through 12. You can always pause this, rewind it, and rewatch. But we're going to talk about diameter. That's going to be important. Diameter is going to be all the way across. So we want to name one. We want to find the circumference. Circumference is going to be the entire outside of our circle. Okay, we're going to want to, in this case, utilize all the things that we are given. So we need to make sure that we understand what's given to us. So it says let the radius of circle A, in this case this is circle A because the center is A, be 6 centimeters. So diameter is going to be pi times d. So the diameter, sorry, my apologies, is going to be double of the radius. So in this case the diameter is equal to 2 radiuses, and that's going to just be 2 times 6, which is going to be 12. So EB, if we wanted to be more specific, E to B is equal to 12 centimeters. The circumference, though, for this is going to be either pi times diameter or 2 pi times the radius. Since we already have the diameter, we're just going to use that. This is going to be 12 pi. Now, I'm going to say to leave it in pi form. There's really no reason unless we're looking for an approximation. This is an exact solution. It should be 12 pi centimeters. From here now, I need you guys to help me find measures, which are angles. Remember, measures are angles. And then lengths are going to get us actual lengths. So parts of the circumference. And you can see here that this is our dividing line between lengths and measures. So let's find one measure and let's find one length. So we're working with number 13. We're going to find the measure, the angle of E to F. And since E to B, that is our diameter, that means we have a semicircle of EFB. So this is a semicircle. What's in green here? This is a semicircle. So that must equal 180 degrees. If 60 degrees is already taken up, right here, I just circled it, then we must have 120 degrees left. So the measure of arc EF is 180 minus 60, which is equal to 120. To find the length, the actual outside distance from E to F, only now the green part, I'm going to erase the rest, we need to take a part of the circle, so 120 degrees, out of 360 degrees, and multiply it by our circumference, which is 12 pi. Now, if we're using some math here, you can always plug this into a calculator, one fell swoop. I'm going to keep it in terms of pi. 12 over 36 is really 1/3. 1/3 of 12 pi, well, that's just going to get me 4 pi. So that is my length of E to F. That is that outside measurement, which is in green. Now you're going to have to do the same thing for the major arc of DCF. It's going to take a little bit more. You're going to have to add up all those degrees. But it's the same premise, so give it a try. I'll make sure to post the key. And you're also going to need to find that length of DCF, which might get you a weird number since it's going to be something a little different. You might want to change this one into a decimal if you really need to. Now, let's talk about area of a circle and area of a semicircle. Area of a circle is pi times your radius squared, and the area of a semicircle, well, semi is half, so 180 divided by 360 times pi r squared. Well, we already know what the radius is. The radius is 6, so we just substitute it in. So pi times 6 squared. In this case, 18 over 36, well, that's really 1/2 pi times 6 squared. So 6 squared is 36, and we have pi. Now we need to cut that in half to get our semicircle, and that's going to get you 18 pi. And remember, this is in units squared, so we need to put centimeters squared for each one of these. Now I'm going to choose to do 19, so you can see it. I want to find the sector area, or area of the sector of DAC. I'm going to highlight that, DAC. So I am going to find the inside area of this part of the circle. I'm going to highlight that right here. Okay, well, this is 90 degrees out of the whole entire circle, 360 degrees, times pi times r squared. Remember, this is part of the circle times the whole area. And that's going to get me the sector area. So I'm going to put it over here on 19. I have 90 over 360 times pi times 6 squared. We already know that's 36 pi. This is really 1/4. 90 over 360 is really 1/4. You can get rid of your zeros, and then 9 divided by 36 is 0.25. So this is 3/4 of pi, 36 pi. Well, 36 divided by 4 is really just 9 pi centimeters squared. I'm going to leave it in pi form. Make sure you do the same. I need you guys to find number 20, which will be FAB. It's going to be a little bit different. It's going to be a little bit messier of a number, and that's okay. I did the easy example. You guys can do the hard one. I'm sorry. But I hope you guys can see the patterns, and I hope you're using your notes for today. That's what's going to get you through this entire worksheet. I hope you have a great day. If you have any questions, please feel free to reach out.